Welcome to Business Calculus, Elasticity of Demand. Suppose you're responsible for setting the price of milk at a grocery store. Assume that raising the price by 50 cents will decrease demand by 200 gallons. If your goal is to increase revenue, is it correct to raise the price in the following scenarios? At $2 per gallon, there is a demand of 1,500 gallons, and at $3 per gallon, there is a demand of 1,000 gallons. If we calculate the changes in revenue, we see that the revenue at $2 per gallon increases from $3,000 to $3,250. So it is correct to raise the price. But if the price is already $3 per gallon, if we raise the price by another 50 cents, we see that the revenue decreases to $2,800, which makes that price increase incorrect. The phenomenon that relates changes in demand and changes in revenue is called the elasticity of demand. The elasticity of demand is defined in the following way. If we let the price P and the demand X for a product be related by the price-demand equation X equals F of P, then we say that the elasticity of demand at price P, E of P, is given by the negative quotient of the relative rate of change of demand and the relative rate of change of price. This is simplified to negative P times F prime of P divided by F of P. Now, you need to make sure that you write the price-demand equation in terms of P before using this formula, which is different because we usually solve it to be in terms of X. Let's do an example involving the elasticity of demand. Marketing research has determined that a new style of smartphone case has a price P and a demand X given by the equation X plus 1,000P equals 40,000. We would like to determine the elasticity of demand at the following prices. P equals $8, P equals $30, and P equals $20. Now, to get started, the first thing that we have to do is write our price-demand equation as a function of P. So we're going to start by subtracting 1,000P from both sides of the equation. And then we see that a factor of 1,000 can be pulled out from both of our terms, which leaves us with 1,000 times the quantity 40 minus P, and we now have our expression as a function of P. Now that it's written as a function of P, we can use our elasticity of demand formula, which is negative P times F prime of P all over F of P. Okay. So substituting in our price-demand equation, we get negative P times 1,000 times the quantity 40 minus P, and we're going to take the derivative of that whole thing, and then we divide by F of P, which is 1,000 times 40 minus P. Okay, now we have negative P. We want to take the derivative of the function in the brackets here. 1,000 is just a constant multiple, so that comes down next, and we're left with the derivative of 40 minus P, which is just going to be negative 1. As we have negative 1 times P. And then we divide by 1,000 times the quantity 40 minus P. To simplify, we see that our negative signs are going to multiply and equal positive 1. And our factors of 1,000 are going to divide out, so we are left with the very simple expression P divided by 40 minus P. All right. So this is our elasticity of demand equation, and now we can start calculating the particular values that we were asked to look at. We'll start with the elasticity of demand when P equals 8. So we plug 8 into our function. We get 8 divided by 40 minus 8, so it's 8 divided by 32, which is equal to 1/4. Okay, so here we have a value that's between 0 and 1. Next up, we're going to calculate the elasticity of demand when price is equal to $30. So we get 30 divided by 40 minus 30, which is equal to 30 divided by 10, which gives us 3, and an elasticity of demand that's greater than 1. And lastly, we calculate the elasticity of demand when price is equal to 20. We plug 20 into our expression, and we see that the answer is equal to 1. So we have exactly 1 for our elasticity of demand. Now, this is important to us because the elasticity of demand has interpretations associated with it based on if the number is between 0 and 1, greater than 1, or exactly equal to 1. Those interpretations are given in the following chart. If the value is between 0 and 1, we say that demand is inelastic. That means that demand is not sensitive to changes in price. If we change the price a certain percentage, the demand is going to change by a smaller percentage overall. And the effect that that has on the revenue is that price increases will increase our revenue. If our elasticity of demand is greater than 1, we say that demand is elastic. That means that demand is sensitive to changes in price. If I have a percentage change in my price, that will give me a much larger percentage change in demand. And the effect that this has on our revenue is that price increases will decrease the overall revenue. Typically, elastic demand goes along with our situation of changing the price of milk. If I change the price a small amount, the demand changes greatly. For example, if I make milk 25 cents or 50 cents cheaper per gallon, you expect people to flood into the store to buy large quantities of milk, more so than they would normally. And lastly, if our elasticity of demand is equal to 1, we call it a unit demand. That means that a price change is roughly equivalent to the percentage change in demand for that item. So you can play with the prices a little bit, but it's ultimately not going to have very much effect on the revenue that you generate. This graph here is a graph for the revenue of the problem that we just looked at. And I wanted to use it to explain what's happening. Now, as we move in this direction, we are talking about price increases. And if we have a price increase, we see that in this region of the graph, we also have a revenue increase. This is opposite from the behavior that we see on this side of the graph, where a price increase here generates a revenue decrease. And it has to do with the value of the elasticity of demand. On the left-hand side of the graph, we have inelastic demand, so price increases give us revenue increases. And on the right-hand side, we have that a price increase gives us a revenue decrease. So keep this in mind when you're looking at the values of the elasticity of demand. All right, and what I would like for you to do is, using the price-demand equation from our example, x equals f of p equals 1,000 times 40 minus p, to determine the elasticity of demand when the price is equal to $24. Here are some potential responses. And I would like to thank you very much for listening.